Hello everyone, my name is Djamel Ramoul. I'm a sales engineer at iBwave. For those of you who don't know iBwave, we are the worldwide standard for wireless design and planning, mainly for cellular. We've been around for like 16 years or 17 years now. So we do all kind of technology, not just Wi-Fi, so it's mainly cellular historically. I'm here today to talk about the difference between Wi-Fi and private LTE in the CBRS band design. So if you used to do Wi-Fi design, what are the differences if you want to start doing LTE design or private LTE? Because there's slightly different stuff when you're doing private LTE since you have more channel. Let me start with a little bit of background about myself, since this is the first time for me here at WLPC. I was born in Algeria. It's the biggest country in Africa. Those of you who don't know Algeria. Anybody from Algeria here? Just by chance? No. So I started engineering school, focused in telecommunication. I was the campus LAN administrator. I got my first certification back then, CCNA, and I wanted to become a network engineer. But in 2007, I started in the cellular industry. It started my career with a wireless provider there, and it was mainly about 2G and 3G installation and maintenance. I was like climbing towers and all kind of stuff, and also point-to-point microwave. Then in 2009, I moved to Canada, and there I started working with Rogers, which is a wireless carrier too. And at that time, they were starting rolling out LTE. It was just massive rollout. It was just hundreds of projects. And then I started doing DAS and small cell design for LTE, and obviously using the iBwave software. And I ended up being called at Rogers the stadium guys, because I started doing mainly stadiums and event venue and like dense capacity venue. Then in 2017, got my master's degree and joined iBwave. So what I'm telling you all of this is because when I was working at Rogers, one day, my boss told me, I have a challenge for you. And we have an arena. It's like the equivalent of the Madison Square Garden in Canada. And this arena has a capacity problem. And we want somebody with out-of-the-box thinking to solve this capacity problem. So what usually happens in the LTE is that for capacity, they put all the possible channel in a sector. And there is not many channels. You have 2 or 3 channels. Historically, the LTE devices were not supporting all the channels, so you have to put them all in the same sector. You can't take the risk that you don't have coverage for one channel and have another channel. So it was basically a lot of interference. And if you're in an arena and it's closed, you have the ice for the hockey, there's a lot of reflection. It was just a nightmare. So then we said, like, why don't we use Wi-Fi best practice? In Wi-Fi in 2.4, they use 1, 6, and 11, and it just keep that separation, trying to minimize the interference. And this was the first time we applied this. So we had 3 channels, 1.9, 2.1, 2.6 gigahertz. And we put small cells, so we reduced the coverage into like small packets, or by seed section, let's say. And the coverage was by channel. So the channel were bleeding, obviously, if you have a cell, so that the channel will cover this way and this way. So you have at least 2 channels covering, so you don't have this problem of having only 1 channel covering. But the result was an improvement in SINAR. So on average, when the venue was crowded, everybody was using their phones, it was about 10 dB SINAR, which is the minimum for LTE to function well. And then we were able to improve it to 14 dB in worst case rope, so it's within the worst 15 minutes. So that's basically your first lesson about designing LTE. Yes, you could do, you could apply the same thing as Wi-Fi. You don't have to do what the carrier are doing, like 1 cell tower having all the channels. If it's indoor, obviously it's easier. And CBRS, you have a lot of channels, well, for now, to use, so separate them. Okay, what are the different best practices if you compare between Wi-Fi and LTE? Well, first of all, well, just 10 minutes, I can't talk about everything. So let's focus a little bit about some design requirement. If you recall, Troy was talking about defining the requirement for your design the first day. So used some of them. Minimum coverage, you're looking in Wi-Fi, minimum next 65 dBm for your RSSI. In LTE, you don't look for SSI, you look for RSRP. RSRP is the reference signal receive power, which is basically the signal level of the resource block. It's not the entire channel, it's just one subcarrier of this channel. And we're looking for neg 105 by default in LTE dBm. If it's a high density area, if you need something higher, like in Wi-Fi, for high density venues, it's neg 55 to neg 50 dBm for RSSI. LTE, it's the same thing. You need to increase a little bit your signal, so we're looking to neg 95 to neg 90 RSRP. Noise and interference. In Wi-Fi, you guys looking for 25 dB SNR and the minimum CCI, or reduce the contention to the minimum. In LTE, since there is no CCI, there is kind of management between the cells for interference. We're looking about SINAR. So that's kind of the CCI is included in the calculation. And the minimum SINAR we're looking for usually is 10 dB and higher. Other thing would be the output power. Usually in Wi-Fi, we want to match the client power with the AP power. And it's around 10 dBm ERP. In LTE, there's no such thing as matching the client power. The power is you can adjust, the BTS or the node will ask the client to adjust the power based on the signal level. So it's not a problem. The only thing you need to pay attention to is you don't want a delta of more than 10 dB between the transmit power from the transmitter and the transmit power from the receiver, from the client or the LTE device. Because you already have a minimum of 10 dB SINAR, you don't want to lose this 10 dB. So you end up at 0 dB SINAR in the uplink. So you need at least something positive in the uplink. Regarding channel width, in Wi-Fi, it's not recommended to use wider channel. In LTE, is the opposite. You use wider channel. LTE is just more efficient with wider channel than smaller channel. In terms of the overlapping, we talk about it. But in LTE, you will not find channel number. You will find EARFCN. This is the channel number. So, and the number is like in CBRS, going to be something like 55,740. And then if it's 20 meg, so the next channel is 200 plus 200. So it's 55,940 and so on. So this is something you need to learn. In terms of mobility, that's a whole topic. We can spend an hour talking about it, but briefly, in Wi-Fi, you want some AP overlap for your roaming. In LTE, we talk handover, because roaming is when you roam to another carrier. So it's handover or handoff, depending which country. And we're talking channel overlap. So it doesn't matter which node. It could be the same node having two different channels, and they could have inter handover, or you could have with another channel or the same channel. So it's basically how you manage your channel boundaries. And then how about the predictive modeling? Yes, it's really important, like Nick was saying yesterday. And if you want accuracy, you need to calibrate it. In Wi-Fi, you might use AP on stick survey, but in the cellular world, you will mainly hear about CW test, because you may not have the transmitter available or not be or AP LTE, let's say. So you use like whatever signal in a clean frequency, and then you survey it, and then you use it to calibrate your model. We tried to do it for this venue. We get this floor plan. It's not really usable to do a nice building, but we end up doing it. So we kind of did a 3D model. And sorry, it was too quick. And then if you do the coverage, for example, this is what it looks like in iBwave. If you're targeting neg 105, you see just two. I don't know if you saw the Celona CBSD. They called CBSD in the CBRS Alliance called them CBSD, but the manufacturer may call them E node B or small cell or LTE AP, so depend on the manufacturer. So two of them were enough to cover the entire conference, because you have 30 dBm ERP per 10 megahertz channel. So if you're using 20 megahertz, actually, you can transmit 33 dBm. And it's enough for neg 105. Then if you're looking for SINAR, Assuming they are on the same channel, it handles very well. It's just in between them, it's bad. But if you're looking for more capacity and you add more, then the signer will degrade really fast. And this is the difference, because now you have 2 more interferers. So you're adding so every 2 interferers, 3 dB, 3 interferers, they're in 4.7 dB higher. So sometimes you will end up with negative values. So it's better to have a better frequency planning. And then the question is, how do I survey this? You may have seen me walking with a device surveying the Ceylon private LTE network. And what we were using is the PCTEL scanner on the app. So in iWave, you have 2 ways of doing it. If you're using the PC software, you have a manual import and export there's many tools out there doing LTE survey. There's a lot of hardware, but the main one is the IBFlex from PCTEL. If you're using the mobile app, which I was using, it's kind of automatic import and export. And it's going to look like this. And this data collected, you could actually use it to fine-tune your predictive model to adjust the wall loss automatically, and you do your what if. And if you want to learn more, I highly suggest you check my presentation during Wi-Fi Trek in Nashville, and you can find it in YouTube. That's all what I have. Thank you.